Hello everyone. In this video, we will understand one of the most fundamental concepts in soil mechanics, the phase system of soil. Once this concept is clear, most of the soil mechanics numericals will feel much easier. In this video, we will be quickly learning the composition of soil, the three-phase and two-phase diagrams, and very useful equations which will help us in solving geotechnical engineering problems. So let us start. What is soil made of? A soil mass consists of solids and voids. Voids are the empty spaces between solid particles. Voids may be filled with air, with water, or partly with air and partly with water. Thus, a soil mass consists of solid particles, air, and water. The proportion of these three constituents and their interaction governs the properties of soils. For convenience in calculations and easy understanding, all the solid particles are segregated and placed in the lower layer of the three-phase diagram. Similarly, water and air particles are placed separately. Please note that the three constituents cannot be actually segregated. The phase diagram is a simple diagrammatic representation of a real soil. Next, let us see the case of a completely dry soil. There will be no water phase, just solids and air. This is a two-phase system. Consider a fully saturated soil. It means all the void spaces are filled with water. So only solids and water, again a two-phase system. This three-phase diagram forms the basis of soil mechanics. Almost all the formulas come from this diagram. Normally, we write the volumes on the left side and weight or mass on the right side. Vs is the volume of solids, Vw is the volume of water, and Va is the volume of air. Volume of voids Vv is the sum of volume of water and volume of air. Total volume V is the sum of Vs and Vv, that is Vs plus Vw plus Va. Similarly, Ws is the weight of solids and Ww is the weight of water. Weight of air is negligible and taken as zero in soil mechanics. W is the total weight. W equal to Ws plus Ww. All these can be written in terms of mass also. In an absolutely dry soil, there will be only two phases, solids and air. Vs is the volume of solids and volume of voids Vv is equal to Va. Total weight W will be equal to weight of solids Ws. In a fully saturated soil, the two phases are solids and water. Total volume is the sum of volume of solids and volume of water. Total weight is the sum of weight of solids and weight of water. Based on the concepts we learned now, let us see some useful volumetric relationships. First one is void ratio E. It is the ratio of volume of voids to the volume of solids. It is usually expressed as a decimal value. Example, void ratio E equal to 0.5. Porosity N. It is the ratio of volume of voids to the total volume. It is expressed as a percentage. For example, N equal to 50%. But in equations, we will substitute it as 0.5. Porosity of a soil cannot exceed 100%, as it would mean volume of voids is greater than the total volume, which is absurd. Both E and N are measures of denseness or looseness of soil. As the soil becomes more and more dense, E and N will decrease. Degree of saturation, S or SR. It is a ratio of volume of water to the volume of voids. It is expressed as a percentage. If the soil is absolutely dry, S equal to 0. If the soil is fully saturated, S equal to 100%. In equations, we will use S equal to 1 in that case. Percentage air voids NA. It is the ratio of volume of air to the total volume. It is expressed as a percentage. Air content AC. It is the ratio of volume of air to the volume of voids. It is usually expressed as a percentage. Both air content and percentage air voids are 0 when the soil is fully saturated. It is because numerator VA will be 0. Water content or moisture content. It is the ratio of mass of water to the mass of solids. It is expressed as a percentage but will be used as a decimal in computations. These are some important relationships. Next, we are going to learn a very important useful relationship between void ratio E and porosity N. Let us write void ratio E. E is the ratio of volume of voids to the volume of solids. E equal to VV by Vs. It can be written as volume of voids divided by total volume minus volume of voids. We can divide the numerator and denominator by the same quantity V, that is the total volume. E equal to volume of voids by total volume divided by total volume minus volume of voids by total volume. We know that volume of voids by total volume is porosity N. So, E equal to N by 1 minus N. We can rewrite it as N equal to E minus En, N into 1 plus N equal to E, or N equal to E by 1 plus E. So if we know the void ratio of a soil, we can find the porosity and vice versa. So we have learned phase relationships in soil, two-phase and three-phase diagrams, and some basic relationships. More equations and numericals will be covered in the next video. Thank you.